Okay, so welcome everyone to this fourth session of the virtual time series workshop for early career colleagues. So this is, as I said, the fourth edition. And today we're going to have three sessions. The first one will be shared by myself, Abdurrahim Taimuti from University of Liverpool. And in each session, we will have three presentations, and each presentation is for 20 minutes. So we will allow questions within these 20 minutes. And so we're going to start with the first speaker, Endong Wang from Mannheim. Endong, maybe you can upload your slides if you didn't do so yet.
Sure, yeah.
Yeah, and
sharing my slide.
Yeah, and Don will present local projections, identify the same policy counterfactuals as empirical and structural models. So, and Don, you have 20 minutes, and the floor is yours. Thank you.
Okay, thank you. Thank you all, and thank the committee to include my paper in the program. And today I'm going to talk about this local projection and policy counterfactuals. Here's the roadmap of today's presentation. Okay, first we talk about why the counterfactual matters and why they're interesting. So it's a very standard exercise in macroeconomics, like people doing these two kind of counterfactuals. The first one, I named this terminology called policy peg impulse response. Basically, it looks at like how shock propagate if we fix a policy instrument for some periods. This can answer the question like, what if the short policy rate has been impacted after an oil supply news shock? The other exercise would be a policy path scenario. That is to replace the realized policy path by an alternative path and ask how outcome would have been changed. So this could help answer the question like, what if lift-off in the post-pandemic tightening episode has started in November 2021 rather than February 2022? And in this presentation, because I only have 20 minutes, so we focus on the first counterfactuals, the policy peg impulse response. So these counterfactuals are typically studied inside a fully specified SBAR or linearized structure models. So there are many papers giving these methods or algorithm to do this kind of counterfactuals. But the limitation is this counterfactual is tied to this fully parametric system with some certain algorithm. And it makes the economic interpretation less transparent. So the standard approach is model-based, but this is not the only possible way to think about this exercise, given the current local projection is so popular in macroeconomics because it's a simple linear regression-based method. So here, this paper is asking this question: is it possible to using local projection to do this counterfactuals, or at least give some, or at least to for the parameter identification purpose? So this is where we have known in the literature, like for the impulse response function, Platt-Morley and Wolf's paper says that local projection and SBAR deliver the same impulse response. So for the impulse response, at least we have this regression-based approach for identification and estimation. And also for the macro counterfactuals, recently there are a sequence of papers talking about sufficient macro statistics. The main story is to do the macro counterfactuals. The sufficient information would be the impulse response functions other than the fully parametric models. So these counterfactual object is some nonlinear functions of impulse response function. So our question would be, can the same regression-based logic, the local projection logic, be used for policy counterfactuals? In other words, if the LP can identify the VAR-based impulse response estimate, can counterfactual outcome also admit this transparent LP estimate? Here is our contribution in this paper. So first, we formalize this process pack impulse response, which study how a shock propagates when the within window policy response is shut down. Under a sequential intervention design, we will elaborate this in the next slides. This design was developed by Xing and Zhang in 1995. But in our paper, we also explore another possibility that's called one-shot design that's developed by McKay and Wolf in 2023. And we showed that these macro-counterfactual objective can be identified by LP-IV regression. Then it will have very simple and straightforward economic interpretation. And we show that the equivalency that under parsing invariance and a linear structure vector moving average envelope, these LP counterfactuals coincidence with those implied by SVAR and linearized structure models, as long as these models share the same impulse response representation. Okay, here I briefly talk about the framework. We suppose we observe the system. We have WT, a vector variable, represent our economy. XT is a variable tied to the shock of interest. For example, XT could be oil price. YT is outcome of interest. YT could be GDP. ZT is the policy instrument. And LT collects remaining variables, possibly partly latent. And we suppose our economy is driven by current and past shocks, a function G of all the past shocks. And ET collects the shock of interest, epsilon XT, and policy shocks, epsilon ZT, and a vector of all remaining shocks, epsilon IT. And we would claim this law of motion includes, like, for example, a SMAR model and linearized structural models. So if you invert the bar operator, you will get a vector moving average model, and which is a linearized function of all the past shocks. And for the linearized structural model, you suppose we have considered a scalar YT equals to 8 times expected YT plus 1 plus UT, and UT follows a AR form. Then this forward-looking equation still have a unique stable solution as a moving average representation. So that just shows that this law of motion is general, includes the VAR and linearized structural models. And the counterfactual is implemented through this sequential design method. It's like we fix the policy variable from T to T plus Q over our Q plus 1 period. And this fixing is implemented through a sequence of policy shocks. So policy shocks intervention through this Q plus 1 periods to fix the policy variable at the baseline rate. And our restriction is imposed only over a finite window Q and not permanently. So it partially addresses the critiques by Hamilton and Harina. And we also assess whether the required shocks are small in case the concern on Lucas critique is less severe. And here is the definition. Yes.
So this is one-time shock, right? Or is it like recurring? Is it one-time shock?
No, it's period by period shocks. So it's sequential shocks from T to T plus Q.
Okay, so we are not looking at the generalized impulse response function here. It's not generalized response function.
No, yeah, here it's just the impulse response, the standard impulse response.
Okay, thank you.
And okay, here is the definition for the policy pack impulse response. So what we have seen in the literature is basically the first equation, but without the tilde. We have a treated economy and we have a baseline economy. But the difference here is we have a pack restriction. We restrict the policy variable zt, zt to zt plus q at the level of untreated, the baseline untreated level. So it means in this counterfactual world, whatever the shock of interest has any value, the policy variable will keep at zero level, as if there were never shock of interest. So the endogenous within window policy response is offset by policy shocks, and this object isolates propagation of shock of interest when the expected policy path over Q is held fixed. So that's the main difference with the standard impulse response. And this equation is kind of the most important equation in the paper is the LP-IV regression, and we use this LP-IV regression to identify this policy pack impulse response. We have a epsilon xt as a regressor, which is a random treatment. But the standard LP has no contour, or it only possibly have past contours. But the difference here is we will have a future contours. This ZTA, DTQ, that's the endogenous policy variable after the treatment from T to T plus Q. And we highlight that this is not a like forecasting contour, but it has a structural interpretation because we wish those policy variable keep fixed in terms of the policy shock treatment. And we will give we'll do identification through the policy shocks. So here, this ZTQ will be endogenous to the arrow, and the next slides we will show the identification. And here the parameter of interest will be this beta, the policy pack impulse response. And we identify this data through IV, which is a vector of policy shocks. So we have this big epsilon include the shock of interest and a vector of policy shocks, which are used to fix the policy variable at their baseline level. This is the exact identification. We have the same number of IV and the endogenous variable. And we have this moment condition, and this beta can be identified through second moment, very easy. And the issue is we need to show that this LP identified as demand is identical to those you get from like structural model or empirical model. So next we will show that equivalently. So we impose this linearized assumption, time invariant impulse response, and policy invariance assumption. So we suppose between the baseline and the counterfactual economy, it uses the same DGP, same model, same impulse response. And you may question this assumption, and our argument is following McKay-Wolf paper, policy invariance across the baseline counterfactual economy is possible when the private sector block is unchanged and the policy matter only through the current and expected future path of the instrument. So if the policy intervention is only through the future path of the instrument, then the whole model will keep the same. And this equation will be the key equation to identify the sequence of shocks which are used to implement this counterfactual scenario. ZTQ, that's the baseline policy value. Z-tilde, that's the counterfactual policy value, and there will be a gap between these two. And we will fill this gap by using a sequential policy shock, delta Q. Delta Q, that's the sequence of shocks used to close the gap between baseline and counterfactual economies. And psi Q, that's a matrix, that's a square matrix mapped from those shocks to policy instruments. So we will solve this equation, and in the paper we show that there is a unique solution for delta. Once we solve this delta, we can solve the policy-packed impulse response. It consists of two parts. The first part is theta, which is the original impulse response, so no restriction, very standard. And the second part, that's the part coming from our restriction. Because we impose this restriction, and that restriction will have endogenous effect on our economy. So this psi, that's the measure of the response to these policy shocks. And delta is solving from the previous equation system. And by algebra, we show that this beta is identical to beta LP, which is identified from local projection. Next, we show that if you don't like this LP or you don't like this closed-form formula, you still follow the standard way, like the Sims-Zas method, to do this counterfactual in a standard SVAR, you will still get the same results in population. So you suppose you have a SVAR like ALWT epsilon T, and they share the same moving algebra representation. Because the algorithm proposed by Sims-Zas is to use those policy shocks period of periods to fix the policy value Z at its baseline level, which basically just use the shock to fill the gap between the baseline policy variable and the counterfactual ones. And if you do this exercise, you will get the same equation system as the one I showed you in the previous slides. After you get those shocks, you remove these effects of those shocks.
5 minutes.
Okay,
Yeah.
I'll finish soon. From the baseline impulse response function. Next is if you wish to use a structural model, a forward-looking model to do this counterfactuals, as long as it has this moving average envelope, which means you have the same impulse response matrix. You do this period by period counterfactual to use the shock to fix the policy variable. You end up with the same equation system, and you get the same size of those shocks, and then you get the same policy-packed impulse response. And we talk about the empirical exercise. I feel it's interesting. So we use the US data and still look at the oil price shock. Given the current situation, we feel like it's interesting to look back those oil price exercise. We fix the policy response by 3 months, by 12 months, and 24 months. We use the Kesey method to identify the oil supply news shock, and Bauer-Swenson IV to identify monetary policy shock. Equation 2, that's our LPS demand. We have a oil shock, that's a random treatment, and we have a endogenous controls, FFR from T to T plus Q. We highlight that LP is used for identification, and for the estimation, we estimate the impulse response and plug those impulse response into the explicit formula to obtain the packed counterfactuals. And you may wonder why we step back to the nonlinear method to do the calculation. Because when Q equals 12 and 24, the effective sample size shrinks very quickly and outcome becomes very stable, the LP outcome. But we argue for the Q equals 3, LP is still feasible with the hack inference. And here is the result. The first panel, that's the monetary policy shock. The second panel, that's the oil price shock. That's all the ingredient you need to do this counterfactuals. And we have the 3 months counterfactual, we have 12 months and 24 months. Let me just briefly talk about the result. Under the peg, we find out the inflation will be higher, about 15 and 30 basis point, and oil price about 5% higher. Industry production will be damaged for sure, about 0.3 and 1. No, industrial production will be benefit because the central bank does not raise the interest rate. So will be 0.3 to 1% higher in the first year. So systematic monetary policy tightening accounts for an important part of the medium run output decline after oil price shock. That's another exercise. Let me break. So two messages in this paper. Conceptually, we show that policy counterfactuals can be written as an LP regression as a very clear and straightforward causal interpretation. And econometrically, we show that LPIV, structural VAR, and linearized structural models recover the same class of policy counterfactuals under a common linear moving envelope. That's the extension for the LP and SVAR estimate the same impulse response. Thank you. And I welcome any questions.
Thanks a lot, Theo, for finishing a few minutes before. So let me stop the recording and then any question